Hello there. This video is going to be about irrational numbers, and this was a request in the comment section. So if you have ideas for other videos, go ahead and put a comment in and I will try to make a video about that. So this is my attempt at explaining what irrational numbers are. So first we're going to look at that word irrational. And when we think about somebody being irrational, we kind of think about them like being crazy or not thinking straight. But in math, when we think about irrational, ir means not and rational means ratio. So that means we have a number that can't be written as a ratio. So what is a ratio? Well, we can think about a ratio as being a fraction where the numerator and denominator are integers. And integers are just whole numbers or their opposites. So examples of rational numbers would be things like 1/2 or 2/3 or 15/16, or even like -6/7. As long as we have a whole number or an integer in the numerator and the denominator, then we have, these are all rational numbers. So when we have 1/2, okay, we're going to do 1 divided by 2. And to do this division, we're going to put the decimal point, and we're going to put as many zeros as we need. We could always extend the zeros as far as we want. We'll put the decimal point up here, and now we'll start to divide. And we can basically ignore the decimal point from here on out. So 2 goes into 1 0 times. 2 goes into 10 5 times. So 5 times 2 is 10. And we get 0. And once we have 0 here, we're done. We could divide 2 into 0 again and get 0, and then get 0 and keep doing this. But we generally stop, though, once we get to a 0 as the remainder down here. So we see that for 1/2, we get 0.5, and the decimal just ends. So that's one thing that can happen when we have a fraction, and we want to turn it to decimal form. When we do the division, it could just end, and we call that a terminating decimal. Let's go ahead and see what happens when we have a rational number like 1/3. We'll do the same division again. We'll put our 1 here, our 3. We'll extend after the decimal point. We'll move the decimal point there, and now we'll start dividing. So 3 goes into 1 0 times. 3 goes into 10 3 times. 3 times 3 is 9. Subtract and get 1. And now we have 10 again. Remember, we started by doing 3 into 10 to get the 3. We're going to do 3 into 10 again to get another 3. 3 times 3 is 9, gives us 1. 3 goes into 10 again. We're going to get 3 again. And you can see that we're going to have 3's forever. So in other words, once we get back to whatever we started with here, we had 10. We're going to get 10, 10. It's going to keep going on forever. And so we can say that 1/3 is 0.3 repeating. And that's something else that can happen with changing rational numbers to decimals, is that we could have a repeating decimal. And that's actually all that can happen. Either it's going to repeat or it's going to terminate, and that's going to be it. So let's see what happens with one more example of changing a rational number to a decimal. We're going to look at 2/7 now and see what happens. Now we have a 2. And now when we bring down the 0, you see what's happened is we're back to 20. And that's exactly where we started here. So what's going to happen then again is that when I do it, I'm going to end up with a remainder. I'm going to get 14 with a remainder of 6. Then I'm going to have 56 with a remainder of 4. And I'm going to have the same pattern over and over again. And the reason this is always going to happen, we're either going to end or repeat, is because of how remainders work. When we divide by 7, we can only have 6 remainders. Either 1, 2, 3, 4, 5, 6, or we can have no remainders at all. If we get no remainders, if it goes in evenly eventually, that means it's going to terminate. But if it has remainders of 1, 2, 3, 4, 5, 6, eventually, if I keep going long enough, I'm going to end up with the same number again. And when I bring down the 0, I'm going to be starting that pattern over and over again. So every rational number will either end if you get a remainder of 0, or this is the most that remainders it can have before it starts cycling again. And so that's what's going to happen with all rational numbers. Okay, so that's what rational numbers do. They either terminate or they repeat. So irrational numbers are numbers that, when they're written in decimal form, will never repeat and will never end. And knowing that certain numbers are irrational takes a lot of math beyond what we can do today. But we can definitely do some examples of irrational numbers, and we know a lot of them actually. Pi, for example, is an irrational number. It's been shown that no matter how many digits you go of pi, it will never repeat itself. You're not going to have a whole big chunk of this that's going to be repeating over and over again, like we saw when we did 2/7, for example. Most square roots are irrational as well. So like the square root of 2 is about 1.412, and it keeps going on forever, and there's not going to be any repetition. In fact, if we take the square roots of any whole numbers that aren't perfect squares, so like the square root of 3, square root of 5, we can't do the square root of 4 because that's exactly 2, square root of 6, square root of 7, these are all irrational numbers. And if we were to figure out what the decimal form was, we would see that there wouldn't be any repeating patterns. Now, it's also fun to make up irrational numbers, and here's a couple of my favorites. One is that if we just do 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and so on. Well, there's definitely a pattern here. It's not going to repeat itself. And so this number, this decimal number, is actually going to be irrational. We can also do something like making the square number, so like 1, 4, 9, 16, 25, 36, 49, 64, and so on. This decimal number here will never repeat either. And so we can make up irrational numbers all that we want to. Here's a fun one: 0.21, 221, 2221, 2222221, and so on. So we can make up irrational numbers by doing a pattern that will never repeat itself. But most irrational numbers that we come across are like these, where there's not even a pattern there and they don't repeat. So that's a little bit about what irrational numbers are.